Let's look at how we solve a real-world problem. Manufacturing an 18-inch by 20-inch sheet of paper, cardboard, is cut and folded to make a shipping box with a height of X inches. What height should be used if the volume of the box is to be at least 252 cubic inches? So to help us out, I'm going to start off by the drawing. It says it's a rectangular cardboard piece. So 18 by 20 would look something like this, where we have 18 and 20. Now it says it's cut and folded to make a box of height of a certain amount of inches. So we're going to cut from the corners here, and we're going to get a new box after we've cut out the corners after we fold, we'll just make a new box using those lines. So we'd have a box that come in here, and it would look like this, give or take. So it then asks what height should be used if the volume of the box is to be at least 252 inches. Now, I want to remind you, cubic inches, that volume is a formula length times width times height. So it's telling me my volume needs to be at least 252. That means it could be bigger than 252, but not less than. So volume, in this case, is going to be 252. But we don't want this to be equal to it. We want the number to be bigger than or equal to 252. So the number that we get for length, width, and height needs to be greater than that 252. So let's see, what would our equation be? This new equation would now be 20 minus, if this is an x and this is also an x, the same thing here and all the way around, and this would be 20 minus 2x, and this would become 18 minus 2x because we've subtracted an x here and subtracted the x here in this length. And so that's how we could come up with our equation. So we'd have our length is 20 minus 2x, and that multiplies, that's why I put it in parentheses, times the width, which is now 18 minus 2x, and then it multiplies times the height, which is x. I'm going to go to the graph and look at this as F1, this is F2. We want this to be above that. So we're looking for the areas where this is above that. So I'll go over to my calculator. I'm going to go to new document here. And so the first equation, I'm going to type in F1, is the 252. 252. The second equation is 20 minus 2x times 18 minus 2x times x. Now when we press enter, it's not going we can't really see much of that. But here's what I do know, is I know that that other equation is way up at 252. It's a straight line at 252. So I'm going to zoom this out, and so I can see the graph at that point. Rather than choose zoom out, though, I'm just going to go to Windows settings. If I know that it's crossing way up at 252, I know the graph's going to go above it, I'm just going to type in like 275. So the graph should be way above. Okay, now we get our intersections. So we're looking where the graph is above. It looks to me that it's above in these areas here. So I'll go to Menu, Analyze. I want to look for the intersection. So I have an intersection there. And when I analyze, I'll also have another intersection over here. Okay, so now I pulled this over. Now remember, we want this part of the equation, the red equation, to be above the blue equation. So I'm looking for any variable, or not variable, I'm sorry, any window where this is above, so this region here. This goes from the x value, because that's the height. So we have good answers anywhere between 0.844 all the way up to this 6.3. From those values, where the volume is at least 252. You could also write this as in set builder like this. Then these would be our answer values. So at anywhere in there, the volume is at least 252, cutting that amount on each side. Here's one for you to try. Again, I would just recommend F1, F2, and come up with a reasonable window.